Example 5, it says in a DC circuit, the power P dissipated in the circuit is given by the equation P equals Ri squared, where R is the circuit resistance in ohms, and I is the current in amperes. So we have three variables, P, R, and I. So I'm going to start with that. P equals something, R equals something, I equals something. Okay, they specify what the variables represent and what unit, at least the resistance and the current are. Power, it says, so if resistance is ohms and I is in amperes, we have 1440 watts of power, so P is power, right? So if I identify everything they tell me here, it says we have 1440 watts of power and a resistance, a 10 ohm resistor, resistance in ohms, so resistance is 10 ohms. I don't know if you guys have worked with ohms. I think we've done ohms a little bit here, but that, it's a capital omega is the abbreviation for ohms. Like an almost complete O with some feet. That's 10 ohms. What would be the current? Current is unknown number of amperes. And the unit for amperes is capital A. So unit of electrical something. I think electrical force, maybe. Anyway, the relationship between these three variables, P, R, and I, is given in the equation P equals Ri squared. So if I substitute what I know into that equation, leave what I don't know as a variable, I'm going to get 1,440 equals 10 I squared. Okay. And the fact we have that I squared object in there makes it a quadratic term, right? And when we have a quadratic equation, what we're looking for is whether a linear term exists or not, if I to the first power is in this problem, which it isn't, right? When it's just a squared term, a quadratic term, and a constant, step one is to get quadratic term, just letters squared equals numbers. So at this point, I see a 10 in front of I squared. I'm going to divide by 10 to get I squared all by itself. So I squared is going to equal 144. And then finally, if I squared equals 144, that means I is equal to plus or minus 12 amperes. And I probably should have read up on this a little bit more. I think amperes can be positive or negative, so both answers should be assumed. If I find out differently, I'll let you know, though. All right? But again, the current is, the unit is amperes, so that's the current, right? So some number of amperes, so positive or negative 12 amperes is the right answer.